Hello there, welcome to October 2020 paper 1. Here we're looking at question 5. So two compounds, X and Y, are involved in a chemical reaction. The amount in grams of the compound t minutes after the reaction starts are X and Y respectively, and modelled by the differential equations of these two expressions here. Show that the second differential is equal to this thing here. So I think what I'll do to get the ball rolling is I'll differentiate the first equation. I'll call this one the first equation. So I'm going to differentiate the first equation. So it's going to be d squared x by dt squared equals minus 5 dx by dt. And it's going to be plus 10 dy by dt. And then the 30 will just disappear. Okay, so what I could do now is I can substitute in the dy by dt in where dy by dt is. So it's the second differential equals minus 5 times the first differential plus 10 lots of the dy by dt, so that's going to be minus 2x plus 3y minus 4. Okay, so let's expand the brackets on this. So it's going to be the second differential equals minus 5 dx by dt. And then it's going to be minus 20x plus 30y minus 40. Now we've still got this y in here, so we need to get rid of the y. And we're going to get rid of the y by rearranging this expression here. So I've got 30y here, so I'm just going to rearrange it to make 10y the subject. 10y equals dx by dt plus 5x, moving the 5x onto the other side, and adding 30 onto the other side. So now when I come to replace my 30y, I'm just going to times all of this expression here by 3, and then that's sorted because it's 10y on the left hand side. So it's the second differential equals minus 5 dx by dt minus 20x, and then plus 3 dx by dt plus 15x, and then plus 90. And then minus the 40 afterwards. So all of these three bits here have come from 3 times this expression on the top there. Now all that's left to do is just simplify and move everything onto the same side. So therefore we have d squared x by dt squared. The first differentials, we have 5 here and minus 5 here and 3 here. So that would give us minus 2 first differentials. Add it onto the other side, you get 2 first differentials. For the x's, I've got minus 20 here and add 15 here, so that's minus 5, add it to the other side, and I have add 5x. And then I've got 90 minus 40, so this will equal 50. So there we are, part 1 complete. So we've got the first differential proved there. The next thing to do is to now find, according to the model, a general solution for the amount of grams of x at a time t minutes. So basically what they're asking here is to solve this first order differential equation. So first of all, the complementary function, that's the name of it, I almost forgot there, complementary function. So the complementary function is going to start with the quadratic, the auxiliary equation, m squared plus 2m plus 5 equals 0. And the roots for this, if we will need to complete the square, m plus 1 squared minus 1 plus the 5 equals 0. Let's move that thing onto the other side, so it's m plus 1 squared equals minus 4. And square root, and move the minus 1 onto the other side, so it'd be plus or minus 2i. So therefore, the complementary function is going to be x equals e to the minus t brackets p cos 2t plus q sine 2t. Okay, so it's that, because that's the general form. What happens here is the -1 goes on the power of the exponential, and the 2, don't worry about the plus or minus bit, the 2 goes inside the sine and the cos. That's just something to remember. That's just a form for when your complementary function is a complex root. This is your answer for the complementary function. Okay, so the next bit, that's the complementary function. Now we want the particular solution. So now, just from observation, if I set x equal to 10, that's going to be 5 times 10 gives you 50, and then any first or second differentials will just be 0, so therefore on the particular solution x is equal to 10, so therefore the answer to this question in total is going to be x equals e to the minus t brackets p cos 2t plus q sine t sine 2t plus 10. There we are. So this is now the general solution. What makes it a general solution is I don't yet know what the values p and q are. So that's the general solution for part B. Okay, so moving on to part C. Part C is find, according to the model, a general solution for the amount in grams of compound Y at time t minutes. Now, what I did was I looked back in my equations. Now, this equation that I've just found in part B is definitely going to be helpful. And then in part A, to work out what Y is equal to, I've earlier found that it was equal to this expression here. That's 10 lots of it. So I'm going to divide all of that by 10 eventually. So what I'll do now is I'll first of all kick the ball off by differentiating the x expression that I've just found, because y is going to be a tenth of all of this added together. So dx by dt is going to equal, now the first thing I need to do is identify, this is the product rule, it's going to be this bit times this bit, so it is the product rule. I'll simplify it in a little bit, but it will be the product rule. So it's going to be, differentiate the first thing first, minus e to the minus t, and then keep this whole bracket the same, p cos 2t plus q sine 2t. So that's the first bit differentiated, the second part kept the same. Let's now do it the other way around. Plus e to the minus t, and then it's going to be minus 2p sine 2t. And the second bit's going to be plus 2q cos 2t. And then the plus 10 will disappear. Now what I'm going to do here now is I'm going to simplify. Factorize out the e to the minus t, and then I'm going to factorize the cos bits and the sine bits. So for cos, it's going to be minus p and plus 2q. That'll be the coefficient of cos 2t. And then it's going to be plus, and then on the sine it's going to be a minus q and a minus 2p. So minus 2p and minus q. That's going to be the coefficient on sine 2t. Okay, so there we are. So that's the first differential. So now what I need to do is I need to do the first differential, add 5 lots of x, add 30, and that will give me 10y. So let's do it, try and do it all in one go. So y is going to equal 1/10 of, so it's going to be the first differential, so that's going to be e to the minus t. Now let's try and do all the cos bits all in one go, because this bit's e to the minus t as well. So it's going to be 1 lot of this, add 5 lots of this, so that'll make it 4p plus 2q. So that'll be minus p, add 5 lots of p, that'll make it 4p, and then add the 2q. So that's going to make it, that's going to be the coefficient of cos 2t, and then the coefficient of sine 2t will be 5 lot of q, add this expression here, so that's going to be minus 2p, add 4q. And that's going to be the coefficient of sine 2t. Okay, so that's the multiplier on the e to the minus x. Now we need to add the 10 at the end. Actually, no, we need to add 5 lots of 10 at the end, so that would be add 50, and then add the 30 onto the end as well. So we add 30. And then close the brackets there. Now let's expand the brackets. So it's going to be, so now it's going to be 0 point all of these coefficients here, and then add 8. So it's going to be e to the minus t multiplied by 0.4p add 0.2q cos 2t add minus 0.2p add 0.4q sine 2t, and then we'll close the bracket on that, and then it's going to be 1/10 of 80, which will be plus 8. Phew! So there we are, that's the answer for part C. You may want to move the 10th to the front, that's absolutely fine as well, and just keep the whole numbers in there the same. But yeah, that's the answer to part C. Okay, so let's move on to part D now. When x equals 2 and y equals 5, when t equals 0, find the particular solution for x and the particular solution for y. And what that means is just work out what p and q are. So, therefore, when t equals 0, let's do the x1 first. I'm going to get 2 equals e to the power of 0 is just 1, so that will cancel out. And cos of 0 as well, that's going to be 1, so that's going to be p. And then sine of 0 is 0, and then plus the 10 on the end. So therefore p equals minus 8. And now that we know that p is minus 8, that will help us with the second bit here when t equals 0 on the y1. So when t equals 0, I'm going to get 5 equals 1/10. Lots of, on the cos, we're going to get 4 times p, so that would be minus 32 plus 2q. Cos of 0 is 0, sine of 0, so cos of 0 is 1, sine of 0 is 0, so then we'll have the plus 8. So then we'll move that onto the other side, so it's going to be minus 3 equals 1/10. Lots of minus 32 plus 2q. And let's start rearranging it, so it's going to be minus 30 equals minus 32 plus 2q, so therefore it's obvious now that q needs to equal 1. Okay, so there we are. So that's the values of p and q. So now we can write our final answers for x. So it's going to be e to the minus t brackets p, which is minus 8. So minus 8 cos 2t plus q, which is 1, so just as normal sine 2t, plus 10, and then y is going to equal e to the minus t, open brackets, so in the calculator now, nice and quickly, 4 times minus 8, add 2 lots of minus, so add 2 lots of 1, that will give us minus 3 cos 2t. And then on the sine 2t, it's going to be 16 add 4, and then, no, sorry, 16 add 4, so that'll make it 2, so 2 sine 2t. And then plus the 8 at the end. So lovely, there we are. So this is the answers for these second order differential equations. Moving on to part E now, the scientists think that the chemical reaction will stop after 8 minutes. Explain whether this is supported by the model. So when t equals 8, e to the minus t, so e to the minus 8 rather, is equal to 0.000335, which is such a small value. So as this is very small, the number relative to 8, 10 and 8, as this is very small compared to 10 and 8, what I'm referring to here is this 10 here and this 8 here. As this is very small compared to 10 and 8, the reaction is likely to have stopped. The reaction is likely to be very, very slow or stopped. Okay, so there we are. That's the answer for this big 17-mark question 5 here. Hopefully that was a good detailed answer there. Hopefully you found it helpful. Let's now move on to question 6.